Hi there. In this video we're going to talk about equations with variables on both sides. Equations with variables on both sides can be a little bit tricky to take care of because we get some choice in how to deal with them. If we take a look at this equation right here, then the thing we want to do to start is to get rid of any parentheses happening or any distributing that we need to do. So I'll multiply my 3 by my x and by my 2. I get 3x plus 6 is equal to 8x minus 4. And this is the point where we get some freedom of choice in this, because there are really 4 things we can do. As long as we pick something and do the inverse operation of it, we'll be okay. But we need to remember that our goal is to get all of our variables on one side and all of the numbers on the other. So the different things I can do here is I could subtract 3x, I could subtract 6, I could subtract 8x, or I could add 4. And it really doesn't matter which one I do. In this case I'm going to subtract 8x, and I'm going to move my x's all to this side. When I subtract 8x, it goes away from over here and leaves me with negative 5x here, plus 6 being equal to negative 4. Now once we're at this step, we can see that this is really a two-step equation right now. I will subtract 6 from both sides, gets rid of this 6. I now have negative 5x being equal to negative 10, and now I'm down to my one-step equation that we're used to. Divide by negative 5, divide by negative 5, and we get that x is equal to 2. Now, this is the most common case that we'll run into, which is where there is a solution, and it's x equal to a number, or whatever our variable is equal to a number. But there are some other cases we need to talk about. For example, in this one, we need to combine any like terms we can, distribute, and then we'll see how to solve it from there. When I distribute my 2n to my x and my 3, I again get 2x plus 6. I can combine like terms over here. The 3x and the minus x becomes 2x. The 2 and the 4 become 6. Now things start to look a little bit weird here, and some people might see what's going on. But for those of us who don't, let's keep going. I'll treat it just the same and move all of my x's to the left side while moving all my numbers to the right side. When I subtract 2x from both sides, well, it cancels out over here, and it also cancels out over here. Okay, so that's a little weird, but let's keep going. I end up with 6 equal to 6, and I want to move that to the right side, so I'll subtract 6, and that means I subtract 6 over here, and that gives me 0 is equal to 0. When we get down to something like this, this means that there are infinite solutions. What it really means is that any number we put in for x will work for this equation. If I was to look at this first equation again, and I get rid of all these things that I've marked all over it, if I put in 1 for x on the left side and 1 for x on the right side, then they come out equaling each other. So in essence, it doesn't matter what I put in for x because it will always just equal itself. Here's the last kind of equation. I'll distribute, as usual, 4 in with the x and the minus 3, so I get 4x minus 12 is equal to, on this side I'll distribute 2 with the x and 2 with the 1. Now I have 2x plus 2x plus 2. I can combine my x's together on the right side, and I get 4x minus 12 is equal to 4x plus 2. Now, once again, I'll move my x's. Subtract 4x from both sides, and I wind up with negative 12 is equal to 2, because these x's all cancel out. Now, we know that this is not true, so what it means is any value we plug in for x can't make this equation work. There is no solution. And for right now, and where we're at in our math class, those are the 3 different solution types. We either have no solution, we have infinite solutions, or we'll have one solution. We'll get into other kinds later on.